Wanna put linear rods on your 3D printer? Watch till the end.
There are multiple types of 3D printers. There are mainly printers with wheels, rods, and rails. We know that the wheels are cheaper than rods and rails, so most of the cheap entry level 3D printers have POM wheels, and it's good for their speed. So, if you put money on linear rails, then you don't have to worry about anything. Just lubricate from time to time and just start printing. But linear rail costs money and time. If you are going from Delrin wheels to linear rail, first of all you have to find a 3D model that helps you to fit the linear rails onto your 3D printer, or you have to make one. So let's say you have found the 3D model. Now you have to buy linear rails. So for y-axis you have to buy 2 linear rails and 4 sliding blocks. Also, if you want to put linear rails on x-axis, then you have to buy one more linear rail and a sliding block. This can be expensive. If you are thinking about using single block for each rail for y-axis, there is possibility for binding, which can significantly affect your 3D printing speed and quality. But linear rails give superior quality and speed. So if you want quality, speed, and affordability, the middle ground is using linear rods. It is common in mid to expensive 3D printers. Linear rods are fast, reliable, and cheap. But the main problem with linear rods are it can be hard to mount to 3D printers. Any kind of error can cause binding. People have already made mounts for linear rods for Ender 3D printers, but there are a lot of 3D printers that need linear rod mounts. So I made a simple mounting method for all these slots 3D printers to able to use linear rods. So this is the Anycubic Kobra 2 Neo. So I'm right now doing input shaping to show you guys how much is the difference between the Delrin wheels and the linear rods. This is a best case scenario where you can see there is very little vibration. If you are printing very slow, but we can see there is 17.9 if you are thinking about going 10k acceleration. So things you need to convert to linear rods is that we need 2 linear rods for y-axis. I'm only doing it for y-axis right now. So while buying linear rods, I'm recommending you guys to buy 12 mm diameter linear rods. It is less prone to bending under heavy weights. Using LM12UU, which is a linear pairing, I'm recommending you this one. Buy 4 of these and print this housing. It will be in the link in the description. There will be 2 designs. One is this, and next one is this type of design. So if you're thinking that why didn't I not use this kind of bulky stuff, I did try, but there is some issues with the lining, so it can cause binding. So it will not work for every printer. I tried this. I think it requires more skill. I don't have that enough. I think I went for this. This will align with your y-axis extrusion, and I think it's more simple to design and 3D print also on every printer. So if your printer is having end stop switches, then you should use this, or else you can use the regular one, this one. You have to remove the end switch. So if you're having end switches, then you have to mount it like this. You also need 2 bolts for mounting it. You could use your old bolts, but you need 2 more nuts to tighten it. So this is how it should look. Then you have to slide this there. Then take your linear rods and slide it to there. I think I went for a longer one. You could go for a shorter one. After you do that, you have to remove the 4 Delrin wheels and you have to use this one. So it should look like this. So I'm recommending you to not to over tight it because we have to check for binding. So after putting this, you can see that it's not right. What you need to do is loosen this fork and try to make it as stable as possible. So while tightening this, you have to make sure that this blade is actually straight. It can drift a little bit, so you have to make sure and tighten it like this. After you do that, make sure the switch is in right position. It can go away, but I will make a symbol 3D print right there to not move this thing. So first of all, just for testing this, just check whether it's working correctly. You could use your default one, but I will recommending you use this one. It is simple. It's not built by me, but you could use your old one. Still it will work fine, but I will show you a problem. So if you tighten it, you can see that if you look closely right there, can't focus it. The belt will touch this part, so I'm not recommending you use this one. I made this one. It's not made by me. This is the original one. I just extended this piece right here, so I could tight more. You only need to make this one, and you only need these two. You could print it. So this is how it should look, and remaining. The tightening, you could put your heat bed on top. Always remember to use this one. Also, if you are using Anycubic Kobra 2 Neo, it has what do you call it, that switch. You have to remove that. You can't use it with linear rods. So while connecting it, make sure the switch is working. We are going to home the printer. You know that by using this method you will lose some print area. So to calibrate on that, you have to have Klipper installed already. To calibrate the Y, what you have to do is first home the printer, then move 10mm increment until you get a sweet spot between the linear bearing and the maximum position. This is necessary to do if you are going to print anything. It is very simple to do it in Klipper. So you can see the vibration has been decreased a lot, but the acceleration has also been decreased from 10,000 to 6,000, but the vibrations are almost zero. I done one more input shaping. While loosening the belt, I saw you could get a little more acceleration and you will still have almost zero vibration. So to check the quality, I have used Orca test tube. consider subscribing to my YouTube channel and giving it a like if you like the video.
So this is the output. I use Orca Slicer's test tube, and it works perfectly.